Hi and welcome to the lesson about idempotency. Yeah, I think that you heard this term for X time in this course, and it's not without a reason, because idempotency should be your friend as well as automatic retries. So when your task retries, because maybe of some temporary failures of your hardware or maybe of your external dependency that may be unavailable for several seconds, that makes your task fail, when you want to have an automatic retry so you don't need to wake up in the middle of the night and restart your pipeline. So that's a nice thing. But if your pipeline is not implemented with the idempotency in mind, you will end up with problems because of the applied data, because of maybe inaccurate results in your downstream consumers and different things like that. So why I'm talking about this? Just to recall, idempotency is when you run something multiple times and you always get the same results. Let's take an example. So here we have different time windows of 5 minutes with a counter. So apparently it's not a very challenging, I would say, example for stateful processing, but if you implement the data emission part wrongly, well, you will have some issues. Here we can imagine that we have the GC watermark that triggers the result emission, and we write something like that. We have the count, we have the window range, and we have the window ID, which is a random number. So we write it to the database, and now unfortunately our task, or either our full micro batch or full, I would say, unit of execution failed, and we need to retry this task. So again, there is the GC watermark, and since the ID is not deterministic, is a random value, remember, when we have something different, and in the database we will have two records representing exactly the same thing. Here we have the same scenario, but this time we implemented some kind of idempotency logic for the write. We have GC, and this time the ID value comes from something which is related to the data, and this something is immutable, like for example the window range. We have the start and the end time that will not change. So here we write the entry, and when we have to retry this task, well, the ID is the same, and in the end we get only the single record in the database. And what are the consequences others than the ones I showed you with two records instead of one? So duplicate data is the third one. So when you cannot identify your record, your downstream consumers will be in trouble to say, okay, it's a duplicate or not. So simply by providing a kind of ID, which is deterministic, even though you cannot use a kind of key value store to ensure only one line written, even in the case of retries, well, it's a kind of nightmare to deal with that kind of data if you need to know exactly the single observation per person for some input data. Another point is challenging the duplication. So I already introduced the problem here. We cannot identify the record. So for example, if we have some orders and we cannot say that we had 10 orders exactly, well, we may take bad decision on top of this insight. Yes, because when you multiply accidentally your number of orders because of duplicated data, you may be thinking that everything is fine, whereas maybe your marketing campaign is not performing that well in reality. And another part is the overloaded consumers. So it's more from the data mesh perspective. When you consider the data you expose as a product that should be used as much as possible within your company, because it proves you the value. And when you lack the idempotency and you lack the possibility to identify the records very easily, well, it's a kind of bad advertising, and probably nobody will use your product with smiling face. And previously I showed you the idempotency for sample example of a window, and it relies on the event time property of each state as the ID. So here you can see the specific example, and it will also work with entities when you simply combine this event time based property with the entity. So here we have some windows per users, and of course the single variable here is the count, and the window ID and the user will never change. So by concatenating these two parts, you have an idempotent ID generated. Another one is for the arbitrary logic. It's kind of the same principle, but here you need to make a much more effort because the data processing framework will not provide any, I would say, hint to you how to build this ID. Typically here we are building a kind of navigation of a user on a website, an example that we saw already in the previous lessons. And here we have, as you can see, the user ID. So something that will never change is the identifier of the state. And we also have a list of pages. So something that will also never change, because when we close, and remember when we do the GC watermark, we are not supposed to get any more data for the state. And here we simply take the user ID and the first page of the visits list. And again, we rely on the event time here, because yes, 158 is the first record. Okay, and yes, that's all for this lesson. I mostly covered the ID generation, but believe me that it will probably save you a lot of maintenance, and it will also provide a better perception of your data, of your stateful data to your downstream customers. So thanks for watching, and see you in the next lesson.